Welcome to the Curiosity Channel, where we explore the universe through science, scale, and discovery. The Milky Way galaxy is home to hundreds of billions of stars. Many of them are larger, brighter, and far more extreme than our sun. Stars exist in an astonishing range of sizes, from objects barely larger than Jupiter to colossal giants so vast they could swallow entire planetary systems. You've likely seen comparisons where these enormous stars make the sun look no bigger than a grain of sand. But how do astronomers actually determine the size of objects that are light years away? How can we measure something that appears as a tiny point of light in the night sky? And ultimately, which star is the largest we have ever discovered? To answer that, we first need to understand what a star really is. A star is a massive, luminous sphere of plasma composed mostly of hydrogen and helium. Deep inside its core, gravity compresses matter so intensely that nuclear fusion begins. In this process, lighter atomic nuclei fuse into heavier ones, releasing tremendous amounts of energy. In our sun alone, roughly 600 million tons of hydrogen are converted into helium every second. This energy pushes outward, while gravity pulls inward. The balance between these two forces creates what astronomers call hydrostatic equilibrium. In simple terms, a star is a continuous explosion held together by its own gravity. Stars form inside vast clouds of gas and dust. Over time, gravity causes these clouds to collapse. As pressure and temperature rise at the center, fusion ignites, and a new star is born. As fusion begins, the star expands, while gravity resists that expansion, settling into a delicate balance. The visible surface of a star, where light escapes into space, is called the photosphere. This boundary defines the star's radius. Astronomers compare stellar sizes using a unit called the solar radius, which is equal to the radius of our sun, about 700,000 kilometers. There are limits to how large a star can become. If a star grows too massive, the energy produced by fusion can overwhelm gravity, preventing the star from holding itself together. For many years, theoretical models suggested an upper size limit of around 1,500 times the sun's radius. But nature does not always follow our expectations. For most of a star's life, it remains on what's called the main sequence, steadily fusing hydrogen into helium. During this phase, stars do not change much in size. The dramatic growth occurs later, when hydrogen in the core is exhausted. As fusion shifts to heavier elements, the core contracts and heats up, while the outer layers expand outward. The star balloons into a red giant. In the most extreme cases, it becomes a red supergiant or hypergiant. Although the surface temperature drops, giving the star a red appearance, the total energy output increases enormously. Our own sun will follow this path in about 5 billion years, expanding enough to engulf Mercury and Venus and possibly Earth. However, the sun does not have enough mass to grow any larger than that. More massive stars are different. They can continue fusing heavier elements such as carbon, oxygen, and silicon. Each stage of fusion releases more energy, allowing these stars to expand to truly staggering sizes. Measuring the size of such stars is extremely challenging. They do not have solid surfaces, many of them pulsate, and they are often surrounded by thick clouds of gas and dust. For nearby stars, astronomers can measure distance using parallax, which relies on observing tiny shifts in position as Earth orbits the sun. For more distant stars, scientists must estimate distance using spectral data, luminosity, and stellar models. Because of these uncertainties, there is no definitive answer to which star is the largest in the universe. However, several strong contenders have emerged over time. For many years, the title belonged to VY Canis Majoris, a red hypergiant large enough to engulf Jupiter's orbit. Later, UY Scuti became the leading candidate, with estimates suggesting a radius nearly 1,700 times that of the sun. More recent data introduced uncertainty, and its true size remains debated. That uncertainty opened the door for a new champion. Enter Stephenson 218, the largest known star ever discovered. Stephenson 218 lies roughly 19,000 light-years from Earth, near the crowded center of the Milky Way. It resides in a region packed with massive stars. Yet, it stands out as both larger and more luminous than its neighbors. Based on its observed brightness and temperature, astronomers estimate its radius to be more than 2,100 times that of the Sun. If this star replaced our Sun, its outer surface would extend beyond the orbit of Saturn. Light, which can circle Earth more than 7 times, in a single second, would take over 9 hours just to travel once around Stephenson 218. Its volume is nearly 10 billion times greater than that of our Sun. Even more astonishing, this star may not have reached its maximum size yet. As it continues to evolve, it may expand further before eventually collapsing in a powerful supernova. When that happens, it will scatter heavy elements into space, the same elements that form planets, oceans, and life itself. History suggests that Stephenson 218 may not hold this record forever. As our technology improves, even larger stars may one day be discovered, but for now, it stands as the most extreme stellar giant humanity has ever measured. If you enjoyed this documentary, please like the video, subscribe to the Curiosity channel, and share it with someone who loves learning about space. Your support helps us continue exploring the cosmos together.